I've got my ticket for the long way round, the one with the prettiest of views. It's got mountains, it's got rivers, it's got sights to give you shivers, and it sure would be prettier with you. Sound is a wave that is created by vibrating objects and propagated through a medium from one location to another. Sound is a longitudinal wave. The motion of the individual particles of the medium is in a direction that is parallel to the energy transport. So you can imagine a slinky being pushed in a line, so it bunches up like so, and then being pulled back so it spreads out again. This results in the compressions and rarefactions in the air that you can see above, making the wave a pressure wave also. The compressions are the regions of high air pressure, and the rarefactions are the regions of low air pressure. Since this is a longitudinal wave, the sound does not actually have peaks and troughs. So the wavelength is measured from one compression to the next or from one rarefaction to the next. The lines here show the differences in pressure. They are more imaginative than actual waves. So the frequency of your sound, so the frequency of the compressions, relates directly to the pitch. So a high frequency means that you have a high pitch, and a low frequency means a low pitch. Consonant sound waves are waves of different frequencies that are particularly pleasant to hear together, and they are the basis for music. The intensity or loudness of the sound is the amount of energy that is transported past a given area of the medium per unit of time. So as distance increases, the intensity decreases. Now, I'm sure you've heard from people in your life, my grandma says it all the time, when you're listening to your music, that's not music, that's noise. That's technically incorrect. The difference between music and noise is math. The human ear is comprised of the outer ear, the middle ear, and the inner ear. The outer ear collects and channels the sound through the ear canal here to the eardrum and to the middle ear. In the middle ear, the vibrations going through the air are transformed into vibrations in the inner bone structure here. And those vibrations transform into compression waves in the inner ear, which goes through the inner ear fluid to the nerve, which sends a transmission to the brain. The human ear can detect intensities, how loud or soft something is, as low as 1 × 10⁻12 watts per meter squared. That's tiny. And frequencies below 20 hertz and 20,000 hertz, which is a huge range. In comparison, bats can hear up to 120,000 hertz. The quality of sound or timbre is important, or is dependent on the natural frequency of the object. That's why the same note on a guitar and a piano sounds slightly different, but it's still the same note. Some instruments, like the flute, vibrate at one frequency, and so they're said to have a pure tone. Other instruments are more mathematically complex and produce a rich tone. Now, I'm sure y'all are wondering how we can adjust the notes that we play on certain instruments, because they do have their natural frequencies. So if you just strum a guitar without pressing down on any frets, it'll just play one chord or note, essentially. So the way that the musician can adjust the pitch is by shortening or lengthening the strings. You can do this either at the beginning of your piece by adjusting the knobs at the top to tune the guitar, or by pushing down on the frets during your song. The pushing down on the frets causes the vibrations to stop shorter, so there's less density to go through. Wind instruments use the tube to act as a vibrating air column. The vibrations are caused either by the vibrating reed or the lips, which it depends on what sect of wind instruments you're in. You have brass and you have woodwind. And the length of the column can be changed by pushing the buttons that you see here, or by sliding the tube of an instrument, like a trombone, to change the frequency. For the voice, it's a little more complex, which is why I'm very proud to be a singer. The sound begins with the vocal cords, which are just two skin-covered flaps of muscle. I didn't want to show a picture because they're kind of gross looking. The vocal cords open and close to allow air in and out, and they're the most important to creating sound because they are what create the pitch. The pitch will depend on the number of times per second the vocal cords collide with each other, and that's what creates the vibration. The larynx, which is right here, the top of it is your Adam's apple, can also assist with vocal tone by raising and lowering. So when men sing in a falsetto, it's raised quite a bit, and then when they're talking, it's lowered back down. The larynx also assists with creating vibrato. To use vibrato, singers learn pretty much subconsciously how to relax and contract certain muscles in their larynx, and it causes that nice, oh, I can't even do it on command, but it's like a shaky, beautiful sound. Other refinement of the sound occurs in the mouth, where adjusting the resonant space by saying e, ah, oo, or placing the sound in a different portion of your mouth can cause the note to be sharp, flat, or natural. How do I get out? For a portion of my TED Talk, I created instruments made out of vegetables that kind of went bad because they're vegetables, but I created, first of all, a bell pepper shaker. And what I did was I cut the top off and cored it out so it would have a resonant space where the nuts that I used could shake around and create a sound. Another thing you can do is you can use rice and dry the seeds from the bell pepper out. It creates a different, almost pitch, even though it's a percussive instrument. I replaced the top, which was really hard to do. And taped it shut eventually. It was very slimy, so it didn't want to tape. Next, I made a kazoo out of a carrot. I took the drill, very carefully drilled a small hole through the core of the carrot. It was a little scary to do. And it made a lot of juice. So the hole allows the air within the carrot to vibrate. And with a kazoo, you adjust the pitch using your lips and your humming. So it's kind of a mix between a wind instrument and a voice. So I cut the end off of the carrot and drilled a small hole in the top. to allow for a small piece of parchment paper to go over the top. And the parchment paper is actually what amplifies or intensifies the sound. The parchment paper will go into resonance with the air inside of the column and cause it to be louder because there are more particles resounding. Next, I created an udu, which is a Nigerian percussive instrument out of a butternut squash. I used a 1-inch thick drill bit. And got all the seeds out so that there was nothing in the way of the resonance space. And then I used the drill bit to core out the middle a bit more. That's the finished product over there. Next, I used a Japanese radish to make a scraper. I simply cut out the portions of the radish and used a carrot to scrape against them. And the carrot caused the radish to vibrate, creating a sound. Next, I made a bubbler out of an apple. I took a drill bit, cored into the apple a bit, and added some water. I put 2 holes in, one so that the water would have space to bubble, and the other so that I could blow through to the water. Next, I tried to create a conch out of a cabbage. It was rather unsuccessful. I peeled off layers so that the drill might be able to get through it better. This one was really hard. So next and finally, I'm going to take you to another world. While the physics of sound stays the same all around the world, the definitions of what music is changes. What we find beautiful or fun here in the Western world, people might not like in the Eastern world, for example, in Indonesia. Music that is beautiful there, like this. I have to be in there. Is definitely not what most people consider beautiful or even music here. I'll let you listen to this for a little bit.
You need a website. Why not do it yourself? With Wix, you can create your own professional website.
You know, an ad would be good too. So here in the Western world, we would consider a lot of the melodic sounds that they're making in this video to be out of tune. But in Indonesia, they call that their shimmer. And that's the thing that they love most and are proud of about their music. And I'll leave you with this. Thank you.